You can ask these questions based around all of these parameters. So does anybody want to just take a crack at reviewing that? And maybe tell us what all the points mean? Or some, if we can't remember all. Q is the rate of diffusion.
It depends on two different parameters, the concentration gradient.
Which, the concentration gradient of what? Right, partial pressure of the gas, right.
The area is, so the A is surface area, the more the surface area is, the more the diffusion is. D is the coefficient, that depends on the material of the membrane or where's the factors. And the L is the width or the thickness of the membrane you are crossing by diffusion.
Yeah, the distance.
The more the thickness, the less the diffusion.
Exactly. So, does that make sense to everyone? So this is sort of what propels diffusion, and now we're going to talk about how that is represented in our body. So there are two things that come to mind. You know what? Would you guys rather us discuss it now and then do the applied concept, or do the applied concept first and then discuss it? I sort of lectured today, so I don't know if that's what you guys want, like in my earlier recitations. Okay, so there are two things that you should think of when you think of gas exchange in the human body. You have to think of it at the lung, and you have to think of it like the interaction of the lung with the outside air, and then the interaction with your bloodstream and the tissues. So just keep that in mind. So last week we spoke briefly about what regulates your breathing. Does anybody remember what we talked about? Someone brought it up at the end. CO2. The levels of CO2, and Dr. Purcell sort of touched on that again today. So the levels so what propels you to actually inhale and exhale or ventilate, and the rate at which you do ventilate is dependent on CO2. And how is it dependent on CO2? Does the brain just detect CO2? What is the brain actually detecting? The pH. Right, so a drop in pH would mean you have a high concentration of CO2, and what would your body do to combat that?
Hyperventilation.
Well, increase your ventilation rate. Good. So the brain has a sensor called the medulla oblongata, and it's connected, the nerve endings are also connected to your heart. We'll see later that the heart does beat on its own and regulates on its own, and we'll go over that, but primarily your body responds to low pH or high CO2 concentrations, and it controls your breathing rate. In severe drops of O2 in your body, your neurons will, or the medulla oblongata will respond in increasing your ventilation due to severe O2 drops. But primarily, like I said, it's through sensing CO2. So how does it do this? What is so special about CO2? What?
Dissolves in water.
It dissolves in water. I mean, it doesn't have a high, it definitely dissolves more than water. Well, it's up here, so I'll show you it. So CO2 definitely dissolves more than O2 in water, and because of its ability to dissolve in water, it forms what molecule? Carbonic acid, which can then dissociate into acid and its conjugate base. And this is actually what our body senses, and this is the mechanism by which it does this. Does anybody have any questions about CO2?
What was the function of chloride here? The chloride ion?
I think the chloride, I don't think you need to know this, but what I'm trying to remember from...
It's just the reaction towards...
Exactly, so it's just it's sort of balancing the electron charge in the red blood cell, so this reaction could happen. Yep.
What was Dr. Purcell saying about something about a slow spontaneous reaction? I didn't catch when he said that.
Slow spontaneous reaction to what?
He said something about CO2 and that was spontaneous. I don't know the
You're saying
actual.
that
Continuously
CO2,
convert to the carbonic acid.
Slowly by itself, but then with the enzyme it just faster. Is that
Like
what
it
he said?
happens more spontaneously in the red blood cell as opposed to the plasma, which is why.
Oh, okay.
Right.
Is that?
No, that makes sense, right, because obviously an enzyme does what to a reaction? It speeds it up, exactly. So it's going to happen more spontaneously in the red blood cell, but obviously the enzyme is there to make the process more efficient, right? Because our tissues are constantly metabolizing, they're constantly undergoing cellular respiration, and CO2 is being made, especially if you're exercising at a much higher rate. And where does the CO2 come from? What part of cellular respiration? What part? Yes, there are 3 parts to cellular respiration. Huh?
Is the Krebs cycle one?
Krebs cycle, yep. So, in glycolysis, we make NADH, we make pyruvic acid. The pyruvic acid has to move into the Krebs cycle, and in order to do that, it has to get turned into acetyl-CoA. And then, by turning from pyruvic acid to acetyl-CoA, CO2 is made as a byproduct. And CO2 is also made in the terms of the Krebs cycle. Okay. Any other questions on CO2? Okay. So, besides your body, and also keep in mind, we're going to talk about the gradients with O2, but it works the same way. So when your body is picking up all the CO2 and it's bringing it back to the heart to be expelled from the lungs, what do you know about those partial pressures? Is the lung lower for CO2 or higher?
higher.
Higher, right? Because in order for it needs to go than the atmosphere. So it needs to go down its gradient, right? So in order for us to be able to effectively expel the CO2 from our lungs, it has to have a higher partial pressure in our lung tissue than in the atmosphere. The same way we take in O2, right? Does anybody know the partial pressure of O2 in the atmosphere? Well, that's the percentage, it's 760 millimeters per mercury. Okay, so that's very high, right? So you would assume that something needs to be lower in our lung in order for us to take that O2, right? Okay, so, like I said, aside from giving off CO2, our tissues need O2 for what? Metabolism, for cellular respiration, right? This is why we breathe. We don't just breathe. I think a lot of people like disassociate breathing for its actual cause. Like our tissues and our brain and everything needs cellular respiration. We need ATP to function. Our brain uses a tremendous amount of ATP. And that's why if someone goes unconscious or isn't breathing for more than 5 minutes, even if they revive them, their brain will be dead. Because those tissues can't survive like a long period of time without oxygen. Okay, so we breathe to take in oxygen, and oxygen, like I said, isn't as soluble as CO2. So vertebrates or mammals have adapted ways to carry oxygen, and we do this through hemoglobin, right? So hemoglobin has how many subunits? 4. What are they? 2 alpha and 2 beta. And what do they have on each subunit? Does anybody know? How does it bind to oxygen? Iron. So it has a heme group. And iron is a cation or an anion? Cation, right? And oxygen is what? Very electronegative, right? So it's gonna be attracted to that positive cation. What's so special about hemoglobin?
Affinity adjusts with the binding.
Its affinity adjusts with the binding